In this episode, you're going to learn about industrial IoT data ops, the importance of data quality, data standardization, normalization, contextualization, and industrial IoT data modeling. And my guest to help impart that knowledge is John Harrington. John is the co-founder of HighByte, an industrial software development company pioneering the field of industrial IoT data ops with their HighByte Intelligence Hub, a solution for accessing, modeling, transforming, and sharing your plant flow data throughout an extended enterprise. He's previously worked as the VP of Product Strategy at PTC and is also served as the VP of Product Management at Capware Technologies. Welcome to the Fourth Generation podcast here on Industry40.tv, a series of weekly interviews designed to help you learn industrial IoT from some of the world's leading practitioners. So make sure to subscribe and click on the notification bell to make sure that you never miss any of the interviews. If you find this conversation interesting, please review it with 5 stars on Apple Podcast, follow on Spotify, and you can also connect with me on LinkedIn at Kudzai Manditereza. Now here's my conversation with John. All right, John, thank you so much for coming on to the show today.
Thank you, Kudzai. Thanks for having me.
Thank you. Okay. So today I really want to talk to you about the foundations of industrial data ops, which is a field that you guys are pioneering there at HighByte. So I guess my first question is, what is industrial data ops, and what are the challenges that it is meant to address?
Great question, Kudzai. So data ops is a term and a discipline that came out of the IT space and by companies like IBM and Hitachi, and they talk about it as the curation and delivery of data for analytics and visualization. So, in the industrial space, we have those same challenges. How do we prepare data and deliver it to various different systems for the purposes of those systems to either analyze data or visualize data? So, we're focused on that industrial data ops as creating a solution that would just enable you to be able to package up and deliver data. And of course, the key is addressing all of the challenges that are unique in the industrial world in today's environment, right? So the challenges that we see are, number one, we want to streamline how data is integrated and how we can rapidly adopt new systems and get them access to the data that they need. So one thing that we're seeing with Industry 4.0 is a lot more systems are looking to get access to industrial data. So data off the factory floor, data out of the MES system, data from CMMS systems, you name it. Everyone seems to be talking about the cloud for one and trying to use that. And the other thing is analytics, and they're trying to use augmented AI, and they're trying to use machine learning, and just how do we get access to that data? How do we prepare it for these new systems that need access to it?
Okay. So currently we do have some form of data flow mechanism of actually of transferring data from one stage of the factory to the other, which is your Purdue model, your ISA 95. What are the limitations when it comes to that industrial data architecture of your traditional models?
Yeah. So, I think the Purdue model and ISA 95 very much still apply. However, there's some new complexities in this new world. It lays out the different layers of systems, which all still need to be there. But what we're seeing is a lot more systems. So things are getting broken down. It's almost like the concept of microservices or specialty applications for different areas. So instead of having these monolithic layers, we're now seeing a lot of smaller applications because they're much easier to deploy, and they're able to analyze the data, display the data much faster. So I think the layers still apply, but one of the key things that we've seen is the layers apply for the applications, but the data flow doesn't really apply anymore. So many people looked at the ISA 95 model or the Purdue model, and they would say the data has to start at the sensor and flow up from the sensor to the PLC, to the HMI or SCADA, to the MES, to the ERP. What we're seeing is people are putting in sensors, and they want to move that data to the ERP system. It doesn't make any sense to flow it through everything else if that data is not being used for machine control. If it's not being used for machine control, we don't need to put it through the PLC. We don't need to put it through the SCADA system. We don't need to put it through the MES system necessarily. We want to, if we're putting out some sensors to try and capture, for instance, maybe ambient temperature or maybe some vibration of a motor, because we want it for predictive maintenance, then it doesn't make any sense to drive all that data through those systems. It adds additional cost, it slows everything down, and it slows down those systems that have already been validated and work well. So, I think the key is keep those layers in place for the Purdue model, but I think of the data as being a separate dimension and being able to connect the data source to the data target directly or through a single hub. So it's one step to move it from whatever the source is and move it directly into the target system that needs it.
Oh, okay, that's interesting. Now, one impression that I got when I was analyzing and reading more about industrial DataOps is the fact that really it's an attempt to try and come up with quality data. So why is it important that your data needs to be of high quality before you can transmit it to some analytics systems or some external cloud systems?
Yeah, data quality is definitely critical. So there are a couple of things going on with data quality. One is you have to think about where the data is going. So we're taking with Industry 4.0 and cloud systems and data lake, we're moving data from what used to be considered OT type of data. And that OT data would generally be used by the operator, be used by a SCADA administrator or a SCADA user. But that would generally be it. And they would know what all that data meant and any nuances that applied to different machinery. Well, that machine, every now and then the data goes a little haywire and we just wait a couple minutes and then it comes back in, and that's good. Well, now we're pushing that data out of the OT bounds and we're pushing it into the IT bounds. We're even pushing it, so we're pushing it into business professionals who don't know the nuances of the machinery. Not only that, but we're pushing it into people that are looking across the entire corporation. So they're making decisions based on information that they're getting that maybe is pulled from multiple different sites, and they're comparing across that. So now all of a sudden the need to have accurate data is very critical because they don't know, oh yeah, at certain times the machine is turned off, so the data that we're collecting isn't valid. Or they don't know that, that sensor, when it goes out of bounds by a little bit, we just ignore it for a little while and it comes back into bounds. So data quality is critical because decisions are being made both on a business level as well as on an operational level based on this data, and and it's being made by people who don't have as strong an understanding of the source of the data and how consistent it is or quality it is. So that's the first thing I would say. The second thing I would say is that, quality has many facets, right? So when we talk about data quality, it isn't just, when we typically think of data, we think of like a name. And when we think of quality, we think, oh, well, maybe the name gets spelled wrong, like a town's name or a state's name. It gets spelled wrong. Well, in the industrial space, data quality is a little different. In the industrial space, when we talk about data quality, for one, we have to think about usability. is the data being structured in a way that the system can use it? Because that in fact impacts the quality. So is another machine using it, or is another system using it, and do they understand what it is? So for instance, maybe the machine state is numeric, but now the people that are using it, they need to know what that numeric mapping is to textual information. Otherwise, that value is not valid to them. So quality is, it can just be, it's not usable. It also can be incorrect, right? We can just have a bad sensor information. Sometimes sensors are invalid. Sometimes we have sensor drift, and so we need to understand, depending on the quality of the sensor, depending on the information that we're collecting, could we have drift? Do we want to have redundant sensors to make sure that that drift is calculated for and adjusted for? And then sometimes when we think about quality, we're thinking about, is the value available? So sometimes, a sensor can stop working. A device that's collecting it, like a PLC, we can lose connection to that. Networks can have outages. And so oftentimes in the industrial world, when we think of bad quality, we're thinking, well, we lost connection. Could be a variety of reasons for losing connection, but we lost connection. And when we're talking about moving data all the way to the cloud, this gets even more complicated, because we're going through a series of networks, a series of firewalls, a series of devices. And so any one of those could lose that. So when we think about quality, it's a pretty broad category of potential issues, but ultimately to the end user, they need good information at a high rate and consistent. And if we're not delivering that good information at a high rate that's consistent, then they consider it bad quality. So quality is definitely critical as we're moving data much further than we ever did before, and we're moving it out of the scope of the OT domain.
All right. Okay. Yeah, it makes a lot of sense. So now there's some key terms that show up in most cases when you talk about DataOps. Terms like your standardization, normalization, data contextualization. Could you elaborate for us what those terms mean? What does it mean to say data normalization, standardization, and contextualization? And if you can maybe provide a few example techniques that are used in a manufacturing scenario as far as that is concerned.
Yeah, no, I talk about those terms all the time, multiple times a day. It's what we think about a lot, because ultimately, once you can standardize and normalize and contextualize the information, then it can be usable by almost anyone, and it can be usable at scale. So when we think about these terms and we think about what needs to be done, number one, part of the reason why we want to standardize and normalize and contextualize the data is that we want to centralize the delivery of data, and we want to do it in a central location so that we only have to standardize this stuff once, right? So a lot of times in a manufacturing environment, you've got multiple different pieces of machinery. Could be pumps, could be tanks, could be CNC mills, depending on the type of environment that you have. And they each produce different types of data tags. They call it different things. Well, standardization is all about creating a standard set of information you want to capture for that type of equipment, right? And so you want to standardize it to say, look, for the pump, we want to know who the manufacturer is. We want to know where it's located. We want to know the current pressure. We want to know if it's turned on or not. Maybe we want to know what the flow is. And that's all the information that we want to know when we're doing predictive maintenance on that pump. So it's very important to standardize that data set. Now, when we talk about normalization, we're talking about being able to, every time we get the value, we get the same value. It doesn't matter which pump we're getting. So flow. We want to normalize the unit of measure. We want to normalize the unit. Sometimes in a PLC, people will scale the units so that it's easier to handle the numbers. But when we pull it out and put it in our data lake, we need to normalize it so that as we're looking across, they use the same unit of measure, pressure. They're looking at PSI or kilopascals. You want to standardize on that so that you can compare across them, and you can run that same analytic across multiple machines. So the other one, contextualization. Contextualization is critical because you need to know what pump that's coming off. So you may have 50 of those pumps in your facility. Now the pump doesn't need to know where it's located, and the PLC that's driving that pump doesn't need to know where it's located, because that never moves, that never changes. The PLC gets instructions from the SCADA and it reports back to the SCADA, but it never moves, so it doesn't know where it's located. But now that we're taking that data out of the PLC and we're putting it in other systems that we're comparing across, and we're putting it potentially in the cloud where we've got an enterprise data lake, then it really needs to have contextualization. It needs to know what factory it's in. It needs to know where, it needs to know what facility it's in, and what area it's in, what section of the line it's in. May even want to know what's being produced right now. So context is all about adding that information that provides meaning to the value. So it's not just about having a number, 256. It's about having well, that's the pressure. Well, how is it measured in? It's measured in PSI. Well, where's that located? It's the inflow pump of the fluid that's going into, the Section 8 boiler, and it's currently enabled or not. So it's adding all of that information that adds context to the data, which makes it usable and makes it comparable and understandable when people get it out and try to analyze it.
Okay. All right. So this data obviously comes out of systems that don't normally talk to each other, or what you can refer as silos. Do you have any best practices of integrating data from these multiple systems that don't normally talk to each other?
Yeah, absolutely. So, the first thing when you integrate systems is you have to ask, why are we integrating them, right? What is the use case that we're trying to solve when we integrate these systems? So once you identify the use case, then you can say, okay, where's the system and where is the data going, right? Usually it starts with, I want to perform predictive maintenance, and I'm going to do it in the Azure cloud. Okay, that's great. So then you look at, what are the information? I'm going to perform predictive maintenance on my pumps. So then you say, okay, what is the information that I need to feed into the Azure cloud in order to perform predictive maintenance? And this is where we create this concept of a data contract, which is, it's first, what's the data? Any standards that we want to apply to that data? How does the data get transferred into that system? And then we start to think about, what are the sources of the data? So where could we potentially pull data out? What other systems could we pull the data out of to feed it into this target system? So these are the contracts. What are the contracts of Azure to get the data in the analytic? And what are the contracts of the source data systems? Once we've defined those contracts, then we start to think about the data semantics. What do we need to do to transform that data, realign it from the different systems, and get it structured so that when it lands in that target system, it's ready to be used? The key is that you only want to transform it once. You don't want to be transforming it 3 different times. And we really want to be transforming it in a system, not in a bunch of code that was written on the side to try and transform just for one machine or just for another. Because if we can systematize it, then we can replicate it and we can get huge value out of reuse, right? So we think about the data semantics. How do we align it? How do we structure it? How do we transform it? How do we add context to it to make it unique? then we have to think about what happens over time. So these contracts and these semantics need to be maintained over time, and that's really data governance, right? Who controls what's happening? What's going to happen in the source systems? What's happening in the target systems? What if we need more data? How are we going to roll that out? So maintenance is critical. It's a challenge to get all these systems set up the first time. It's even more of a challenge to maintain them over time, because they just aren't, there's changes all over. There's changes in the equipment on the factory floor. We change our products. Sometimes we reprogram the PLCs to make it the process more efficient. And sometimes we have to replace our assets. So all three of those can cause change in the data being collected. We also change our networks. We change our firewalls. We make changes. Our system sometimes needs to be able to change. So we need a structure that we can abstract these different layers. We can make sure that as change happens on one or the other, we can implement that, and it doesn't affect the entire system, and we don't collect data for 3 months that we realize didn't have the information that we need. That's data governance. And it's those best practices around data contracts, data semantics, and data governance. They're really the processes that need to be put in place in order to effectively implement systems like these.
Right. Okay. Yeah. So can you please talk to us about IoT data modeling? What is it, and how does the process look like?
Yeah. So data modeling is kind of it's what we see as the key thing to make all this stuff repeatable and deployable at scale, right? We've seen this huge increase in the amount of data points that are available to us. We see factories with tens of thousands, hundreds of thousands, millions of data tags. Now, we can't, our administrators, we're not increasing the amount of people on the OT team or even the IT team such that they could handle 1 million tags one-off. What we need to do is create abstractions. And we need to create abstractions, map the tags in, and then manage the abstractions. That way, it's, so think about it as, I want to create a model of a pump. That way, I don't have to manage each and every data tag for that pump. Now I just manage the pump. Do I want to send the pump up to Azure? Do I want to send the pump to AWS? Do I want to send the pump to my ERP system or CMMS system? Or do I just, instead of sending the actual flow rate, or instead of sending the actual pressure? So by creating abstractions, we're able to manage the systems much better at higher scale. So that's one of the drivers of creating models, because it allows you for design reuse, and it allows you to create abstractions that you can then work with, which makes everything much more maintainable and manageable. So when we think about models, the biggest thing that keeps coming up in the people that we're talking with is they start with the ISA 95 model for a factory, right? So you've got a factory, you've got an area, you've got a line, you've got a section of the line, work cell, you've got machinery. And if you break it down that way, then you can easily map out your data points, you can map them out to your different systems, and you can work with all of that data, because we're potentially integrating data from the factory, all that real-time data. We're also pulling in data from the MES system. We're pulling in data from the CMMS system. We're potentially pulling in ERP data and lots of other systems of data. You may have machine logs or device logs out there. People want to pull all this data together, organize it all in some sort of a model, hence the ISA 95 or ISA 88 model, depending on the type of process you've got. And then they want to share that and make that information available. So that's kind of the big picture model. But then when you break it down, you get into actual devices. And there's lots of different organizations that have been focused on creating models at the device level, I'll call it. And so we're seeing a lot of different standards organizations and industry groups who said, look, we understand the machinery best in our industry or for our industry. So we'll define the model for it. We'll agree as an industry group, and that way we can start to standardize on that within our equipment, and the rest of the world can start to use those industry standards. So we're seeing lots of different industry groups defining data models at various levels of the ISA 95 stack, if you will. And the key is, how do we leverage the best model for the customer who needs it? So, we've always said the customer, there's lots of industry groups out there. Manufacturing companies should really look at all the different models available. They should look for the ones that closest match them, and then they should customize them and apply them based on their needs. So, a lot of people start with ISA 95, they make a few adjustments based on what their use cases are. A lot of people will start with, if you're working with machine tools, in the US, we have this group called the MT Connect. They've defined what machine tools should look like. In Europe, they have another group called VDMA. They've defined their machine tool model. So depending on where you are, what you're doing, you can look at both of those, compare them, pull out the best of each, and then put them together, and then you can work with your machine tools. Of course, if you're working with building automation, there's the BACnet group. So there's lots of different groups. There's lots of different specifications of machine data that you can work with. But the key is finding the one that best matches your use cases, finding the one that best matches your company, and rolling it out so that you can use it and make use of model data. There's just too much data floating out there today. And if you just put it all into the cloud, people are talking about this concept of, it's no longer a data lake, it's a data swamp. It's just filled with lots of data, but it's unusable. And the key is to put data in your data lake or in your systems that are immediately usable by them. And that's really what we focus on with DataOps, is how do we curate and prepare that data so that when it lands, it's immediately usable. And we think that data modeling is the key to that. Data modeling is the key to being able to do that, and not only do it once, because now when you integrate systems of transaction systems in the IT world, they may just integrate them once and batch loaded data, they do some manual manipulations. In the OT world, with our data, you tend to want to have it to programmatically integrate these systems such that it's happening in real time. It's not a batch process. You want to integrate this and systematize it such that you can see it and you can do it very quickly, very efficiently, and roll it out. So that's the key with the model, is that you systematize these models in an application, and you map all your data points, and then you're good to go. Any new system comes online, it can consume that data. It's very easy to add new systems or add new machinery.
Okay, that's interesting. That's interesting. So now, whenever the issue of data collection, handling, and data transmission is involved, the issue of privacy and security always comes up. So how does DataOps enforce the security and privacy?
Yeah, great question. Security and privacy are definitely critical. We're hearing about, we hear about more and more issues around security, and there's lots of techniques that people are using with regards to securing data. At the lowest level, the key with data security is you want to use secure protocols, right? You want to make sure that as the data flows, it's you're leveraging the security of the different protocols to send the data through. But it's not just about securing that data. It's about, number one, who is the data available to? making sure that the data is only available to the people that need access to it. So you want to make sure that you're securing who has access to it, where is it going. You also want to make sure that the data is that you can see where the data is flowing. One of the challenges that we saw when we looked at a lot of people trying to implement Industry 4.0 is that they started with a proof of concept and they wired up a system that connected to another system, and they did a lot of custom coding to enable that connection and transform that data. And then they moved on to another system and they wired that up, and they moved on to another system and wired that up. And then you had there was no central organization of all these connections. And for the first one or the first two, that was fine. But as that grew in scale, that became more and more of a challenge. I think of it as, the early days when we started networking our computers. When all you needed to do was connect one computer to another computer, you would just use a cable and connect the two. When you would connect a printer and a disk drive to a computer, you would just plug those in as well. But as the number of peripherals, as well as the number of computers grew, we couldn't just connect up a cable to each one of them, one off. What we wanted to do is have almost like a router, right? So DataOps is kind of like that router. It's the ability to pull data in, repurpose it, and send it out. And the key is that you can see where that data is going. So when it comes to security, where are we sending this data? Well, we don't want to have to go to all the target systems and say, geez, are you collecting data from this device? Yes, no. We don't want to go to those devices because many times they're being overrun with requests and they don't even know where they're coming from. What we need is a routing system, and that's where DataOps really plays, where you put in a DataOps solution, and it can be the router. It can be the it ingests all the data, it structures it, and then it sends it out. And by knowing where that data is going, if you have a security breach, you can immediately turn it off. If you're no longer using a system, you can turn off that routing. If you're no longer using a vendor and you are sending some data to a vendor out on the internet, you can turn that off, because now you have visibility into where all that data is going, where it's flowing, and how it's set up. So there's lots of challenges that go very much beyond just, are we encrypting the data, in terms of how do we secure the systems. A lot of people are also using different firewalls and networking approaches to securing the data. So they're using protocols. They prefer using protocols like MQTT, where it's only publishing out as opposed to something on the outside making requests in. So there are different protocols out there that have different benefits from a security standpoint as to how you have to open up your firewall and how the connections are made. So we just recommend, that you look at all of that, you understand where the data is coming from, where it's flowing. You're able to segment things off, potentially federate data from one DataOps hub to another DataOps hub as it's moving through a firewall, into a DMZ, into a business network, up to the cloud. There's lots of different options there, but it's very important to lay out your entire network, to lay out all the systems, all the data that's flowing, and then be able to put in different security checkpoints to make sure that you're staying secure, in that bad actors from the outside can't get in, or even if they're in, they can't see the data, they can't work with the data. So lots of different options there. Lots of different approaches, different companies looking at what data is going where, what data is more easily accessible. We've been hearing more and more people. In fact, it used to be that people were afraid to use the cloud because of security. In fact, they used to say that they wanted to use the cloud because it was cheaper, but they were afraid to use it because of security. And what I hear now is the complete opposite. They say, geez, this cloud is getting expensive. We need to make sure that we control the data that's being sent there and that it's really being sent there for good reasons. But we're using the cloud because it's actually, they've got a better security team than we have on premise. So if we're going to push any data out, we might as well use these big cloud vendors because they've got really strong security teams and they've put a lot of security in place. So sometimes people look at the cloud as a more secure environment. We can push the data up there. That way, of course, in this new world of a lot of people working from home, people connecting remotely, if it's in the cloud, we're leveraging the cloud systems. We're not letting people dial directly into our internal facilities, but they're able to get access to the information that they need. So there's certainly a lot to think about when it comes to security and industrial systems. But there's a lot of technology out there, and there's a lot of experts out there, and there's a lot of potential. So it's really about leveraging the people that know it best, you know, and really, to me, security is all about laying out the entire network and really understanding what's going on, as opposed to kind of having different data paths hidden and people not even knowing, well, we don't really know where that data is. Or how many times have you walked into a factory and people say, well, we've got this computer, it's in the closet over here. We're not really sure what it's used for, but it's been running and we're afraid to turn it off, right? Those days really have to come to an end because that becomes a potential vulnerability if you don't know. So it's about mapping it out and having clarity as to what data is going where and why.
Oh, yeah, absolutely. Okay, yeah. So maybe to close the conversation off, can you talk to us about HighByte, the company? What role do you play in the system, and also HighByte, the tool? You can just give us a brief overview of the functionalities and how exactly it helps people enforce the DataOps.
Yeah, definitely. So HighByte, let's start with HighByte, the company, and then I'll jump into the solution. So HighByte, as a company, we were formed in August of 2018, and so it's a young company, but we're growing, and you know, there's a lot of people interested in what we're doing. So HighByte was actually formed by 3 people. I'm one of the co-founders. I lead business development, and it was formed by myself, Tony Payne, who's our CEO, and Tori Penrock-Hambra, who's our head of marketing. The 3 of us had previously worked together for 8 years at Kepware Technologies. So many of your viewers, I think, have heard of Kepware Technologies. We had all worked there for many years. Tony, in fact, was the CEO. He had worked there for over 20 years. So we'd all worked together. Kepware was acquired by PTC. PTC is another great company. They've had great software technology. They were getting into the IoT space, and they saw Kepware as a huge contributor to their capabilities around IoT. So they acquired Kepware. Well, the 3 of us, after working for PTC for a couple of years, decided, you know, there's still a lot of challenges that need to be addressed in the industrial space. And PTC is a large company. We decided, you know, maybe we should do this on our own. So we had left PTC, and we got back together and said, we think that we could, there's still challenges. You know, we kept hearing about data interoperability and how do we get data to different systems, and how the industrial internet was not going as fast as people had thought. So we started doing a bunch of research, and we said, you know, what's going on out there? What could be causing interoperability challenges? And what we found was that all these new systems are looking for access to the data, and not, you know, a DataOps solution didn't exist. And that's where we said, well, we need to solve this for the industrial space. There was DataOps in the IT space, but not for industrial data. So we formed HighByte around the concept of creating a DataOps solution to help manufacturing companies and industrial companies formulate a data infrastructure, create a data infrastructure to enable industrial transformation or Industry 4.0. So that was really our mission, is creating data infrastructure for manufacturing companies to execute on their industrial transformation goals. So our product is called the HighByte Intelligence Hub. And the HighByte Intelligence Hub is a data hub at its core. It consumes data and it pushes it out. So, just like what we were just talking about, it's a data ops solution, an industrial data ops solution. It allows data to be consumed from OPC servers, so we can get access to that data. From MQTT sensors, we can pull that data in. From enterprise systems that communicate over REST protocol, or we can read and write from a database and consume all that data. Then at the core of the HighByte Intelligence Hub is a modeling engine. So that allows you to create models based on what data that you net. So, that whole ISA 95 stack the ISA 95 model of your factory. If you want to do that, we can create that model. Now, typically when you think of a factory, you've got the machine models, and then you've got the process models, right? That's kind of the MES layer. And you've got the product models also at the MES layer, so that you can log like product traceability and that kind of thing. So you may have different models depending on how the data is being used, but you create all those models, and then it allows you to roll them out across your factory and then ultimately across your corporation. So it's a data hub. And when we looked at the industry, we said, geez, the real challenge of industrial data is the devices, right? The machinery and all the data coming off that machinery. Well, if the machinery is the cause of a lot of the challenges with industrial data, then the people that really understand that machinery, the OT team, the controls engineers, process engineers, chemical engineers, that's the team that really needs to own this system. So we said, all right, we need to build this for the OT team, which, coming from Kepware, we really understand that team, because Kepware was also sold to the OT team. So we worked with a lot of team members from different companies and said, what do you need? How do we build a system that works for you? And the first thing is, it needs to be able to run on premises. This team, all their systems generally run on premises. And if the system the closer it is to the devices, the better, in terms of structuring the data and delivering it to the systems that need access to it. So you want to install it closest to the source data, and then you can structure it and send it out. So we developed the system to be operated by the OT team. We developed the system to be close to the devices, so running on premises. We developed it to be an application, not a programming environment, like Azure or AWS. They're really programming environments, and they've got a lot of tools to accelerate programming. But when you're dealing with really dynamic environments, you really want it to be an application, because with an application, you can set things up very quickly, you can replicate things very quickly and easily, and it's very intuitive on how to set it up and configure it. So we developed it for the OT team. It's you access it through a web browser. You can install it right at the edge if you want, in an IoT gateway, or you can install it in a data server, and it's designed to be operated by that OT team to create those models and then send the data out. And then they can, so that they can be self-sufficient and deliver the data to the systems and teams that need access to it. So that's what the HighByte Intelligence Hub is all about. It's about simplifying and providing a solution for the OT team to be able to do that.
Yeah, awesome stuff. Okay, John, thank you so much for coming on to the show today, and wish you all the best with your endeavors at HighByte.
You're welcome, Kudzai. Thank you very much for inviting me on. It's been great talking to you, and really look forward to having a few more of these sessions. This was great.
Okay, likewise, man. Thank you so much.
All right, bye now.